Start with our final lecture. Like last time, as I mentioned, we're going to be having, well, we had a kind of a self-contained discussion of fluids last time. This time we're going to be talking again about a kind of self-contained set of topics which have to do with rotation, and specifically the kind of amazing inventions that humans have created which utilize the dynamics of rotation. Okay? So the topic of today is gyroscopes. Just kind of a catch-all phrase for all kinds of machines, many of which we have demos of today. Now, the basic idea of how these machines work, these things are basically things that show up because humans made them, exploiting these properties, are based on the fact that angular momentum is conserved. So, of course, we know for linear momentum, if something is moving in a straight line with some huge velocity and a huge amount of momentum, then it takes a lot of force to deflect it. Okay? So this was always true for P, which means that if something's, in other words, has huge kinetic energy, then it takes a lot of force to deflect it from the straight line. Now, the way the gyroscopes work is basically the exact same principle, except rather than having a large momentum vector, it's actually a large angular momentum vector. And what's nice about an angular momentum vector is that you don't need anything moving fast, so to speak. The kind of average motion of the object can be just essentially at rest, but it can just be spinning incredibly quickly. Okay? And what we're going to see is that when this L is huge, we can kind of construct various objects that show up everywhere. Okay? So we can make a list of such things. Okay? These are actually lots of toys that show up a lot in sports. I'll just list a few. One is frisbees. Okay? So frisbees.
Drew, you can't just interrupt someone's lecture like that. What's gotten into you?
Frisbees are something that show up early in your campus free time, and you'll know that they rely crucially on spin. Right? If you take a frisbee and you throw it, and it does not spin with enough angular momentum, sadly it will usually deflect, and then the wind resistance will stop. So it's clear that, we know this from throwing, that if you threw a frisbee with infinitely large angular momentum, that is to say spin in the upward direction, then it's stable. Now, of course, the intuition for why that's true is that if you applied even the slightest torque, let's say from some wind resistance, then it's hard to deflect that vertical orientation of the frisbee. Another example is a football. Anyone who throws a football knows that if you give it a spiral, a lot of spin, then it goes straighter. Okay? It's exactly the same principle. For a football, you want it to travel in some direction, say, in a horizontal direction. But of course, it depends crucially on the stability of the football. So for instance, if it starts deflecting in this way, then the air resistance will stop it, which is why you give it some spin this way. So angular momentum is a way of giving stability to moving objects. Another example where this shows up is actually in firearms, apparently. So when people build guns, and they have like a rifle tube, then what they actually do, in addition to forming a bullet which comes out with some huge velocity, they actually put a small spiral inside the chamber to just spin it. Okay? And when that happens, essentially once the bullet comes out, it's spinning just like a football, and that increases its stability in that rotational direction. Now, if you go to the kind of Wikipedia entry for gyroscopes, you'll see a whole cool list of just amazing human machines that have been created. I'll just give us a couple of them, because I thought they were kind of cool. One is a classic one from...
You will never be a god!
Just going to keep moving on. I think I may slowly back away.
Hey, listen. I don't know or truly trust any of you. But Thanos is going to be here soon looking for infinity.
I agree. We should really start brainstorming. What the hell is he doing?
I looked through all possible futures. I saw all possible tomorrows.
How many did you see?
69,400.
How many were displayed?
All of them.
Oh.
Now, where's that pesky stone?
If you want the stone, big guy, come get it. Catch me!
You're too slow! Let's see how you fare against 6 of us! My spidey senses are tingling. Wait, I forgot my shield.
Come on, Cold Shoulder, let's go! Shit! Come back here, you badly animated overhaul! Muscles don't hide your insecurities! You're the one I want! You can run, but you can't hide! Did your mother raise you like this? Oh, I forgot! You don't have a mother! You're just a piece of mechanical machinery! Feeling noble, aren't you? You should have aimed for the head!
I don't feel so good.
Too soon.
Professor Lewis, this is Nick Sturgey. We're gonna need your help.
Oh god, that was brilliant.
None of my demos will be that.